All right, and so we are going to open up our discussion of exponential functions and table values today. So this gets into our fourth type of function. All right, and so once again, the questions that we're asking you do not change, right? So what type of function, what's its rate of change, and then using that information, right, extending or filling in missing values in your table. So you can see that is reflected in our topics that we're going to cover today. 1.4, I can identify an exponential function from a table of values. 2.4, I can identify the rate of change for an exponential from a table of values. And 3.4, I can find missing values, right, or either in either direction by using your knowledge, all right, of rates of change. All right, so the questions haven't changed, right? So now you should have all four functions in mind, all right, and you're going to have to kind of process and go through, right, all those little defining characteristics to identify which type of function. All right, so now let's look at our opener here. The table of values represents the number of bodaciously green bullfrogs after reentry by Dole, the Department of Amphibian Lovers. All right, so we want to fill in the missing values of the table and then answer the questions below. All right, so we're going to do this a little bit like we did last time, right? Because once again, the pattern may not be as obvious, all right, with this table. So I'm going to look at the time here in years, which is our X column. And once again, notice, all right, that our time in years goes up by 1. So we're just going from the beginning, and then we're going to look at 7 years later. And so what I want you to do now, right, is pause the video and then find the change in Y here. And think about the pattern. So it may not be obvious, and that's okay. We'll go through it together, but see if you can discover what that pattern is, all right, and maybe try to extend your table. So go ahead and pause your video, flip it back on, and we'll see how you do. All right, so hopefully, all right, when you found your first three changes in Y here, you said that it went up by 26, went up by 52, and went up by 104. That's so it's 0 right there. All right, so hopefully one of the first things you noticed was that 26 to 1, 52 to 1, 104 to 1, not constant, right? So you should know right now, definitely not absolute value, definitely not linear, all right? Maybe quadratic, maybe exponential, right? So now the question is, okay, when you found these values, did you see a pattern in what was happening in those rates of change? All right, and here's the pattern. All right, these are doubling. All right, so they're multiplying by 2. 26 times 2 is 52. 52 times 2 is 104. You can also see that in the table. Now here's the key, right, is that sometimes the behavior you can see in the table, but sometimes it's not obvious. And that's why we always look at the rate of change. Because then when we see how the rate of change is changing, sometimes the pattern becomes a little bit more obvious. So here's what we should know. I have a non-constant rate of change. Now I'm down to two choices. It's either quadratic or exponential. If I see a turning point, I know for sure it's probably, and I shouldn't say for sure, more than likely it's quadratic, right? You want to go through your rates of change and verify that, all right? If you don't see a turning point, now we want to look at the rates of change because we saw some examples in our prior lesson to where the turning point isn't always in the table of values when we start looking at quadratics, all right? So we want to look at how this rate of change is changing. If it's changing by the same amount, going up by 2, increasing by 2, going down by 3, we know it's quadratic. Now, if it's changing by a multiplier or a factor, either going up or going down, then we know it's exponential. So in this case, this would be an exponential because my rate of change is doubling. So notice if I want to figure out, okay, so what's the population in year 4? I have to multiply this by 2. So that's 208. All right, so then that means it's going to be 416. And then I want to multiply this by 2. So that's going to need to add another 416. So now it's up to 832. And I want to multiply this by 2. All right, and so I'm going to add another 832. So this is 1664. All right, and then I'm going to multiply this by 2. So I'm going to add another 1664. All right, and if I do that, let me do this real quick, make sure all right, 3328. So after, all right, 7 years, right, those bodaciously green bullfrogs went from a population of 26 to 3,028. All right. So when we think about this, how would we describe the population growing, right? And we would maybe say it's doubling, right? Okay, or increasing by a factor of 2. Increasing by a factor of 2. All right. Why, or what type of function do we think this is? Exponential. All right. So if that rate of change is going up or down by a multiplier or a divider, then we know it's exponential. All right, and why is that? And it all goes back to that rate of change and what we said right here, right? It's doubling, increasing by a factor of 2. All right, so let's look at some key characteristics of an exponential function. All right, so one of the things that we do not see or did not see in this table is that an exponential always has a floor, all right, to its graph. All right. So, and what I mean by that, I'm going to go down to the drawing here, is that if it is an exponential that's going up, like our bullfrog problem here, those bodaciously green bullfrogs, we have a floor here. All right. And if you think back to that opening activity, we saw that with some of the graphs, right? So it gets really, really close to a value here. All right. And then if it's in a decreasing exponential function, it's going down. All right. So exponential decay. So this is exponential growth. This is exponential decay. All right, it's going to get really close, all right, to that floor. So it has a floor. And then the rate of change is going to increase, is increasing, or decreasing by a factor. All right, so the rate of change is increasing or decreasing by a factor. Okay, so once again, it may not be obvious in the numbers, right? So for example, maybe I go 4, 7, 16, and let me see if I can do this real quick on my calculator here. I'm gonna clear that out, 16, and so give you an example here, right? So let's say that those are our rates of change, right? Definitely not constant. And so when I look at like, how do I go from 4 to 7? Notice I go up 3. And then I go from 7 to 16, I go up 9. And then 16 to 43, I went up 27. So notice my rate of change, all right, it's not changing by the same amount like a quadratic, right? Because it would be plus 3, plus 3, plus 3, plus 3, right? But it's increasing by a factor of 3, all right? So 3 times 3 is 9. 9 times 3 is 27. Then I would do 27 times 3, right? We might go the other direction, right? So maybe we have something like this, right? So 50, 34, 26, 22, right? So those are my 3 or 4 rates of change. Now, doesn't seem to be constant, right? So let's look at how they're changing. So notice I went down 16, and then I went down 8, and then I went down 4. So that tells me it can't be quadratic, because if it's quadratic, it would be going down by the same amount every time, like negative 16, negative 16, negative 16, right? Or negative 8, negative 8, negative 8, right? But notice how it's going down. 16 divided by 2 is 8. 8 divided by 2 is 4. Now I would do 4 divided by 2, right? So then it would be like minus 2 right here, so it'd be down to 20. And then I divide that by 2, go down by 1, so I'd be down to 19. All right, so that's what we mean by increasing or decreasing by a factor of whatever that number happens to be. All right, so let's take a look at some example problems. So let's flip over to the back and look at some of the whole class problems. All right, so let's look at number 1. Now, once again, you have to kind of be heads up, because now we have all 4 functions, right? So a lot of the whole class problems will obviously focus on the exponential, but like when you're getting to your group practice, independent practice, remember you got to be ready to go in between all 4 functions. All right, so once again, one of the first things we want to do is look at our table and see if we see a turning point. All right, because once again, if we see a turning point, we know it's absolute value or quadratic. All right, if it doesn't, we just jump into our rates of change and we start looking for constant rates of change. So turning point first, and then we're looking for constant rate of change next. All right, so when you look at our problem here, our table in number 1 here, I do not see a turning point, right? It looks like it's going up the entire time. Okay, now that doesn't mean it doesn't have a turning point, but more than likely, probably not. Okay, so now what we want to do is look at rates of change. And when I look at all my x's here on the left, I can see that they're all increasing by 1. So I'm just going to write all those in. And once again, do the little things, right? Write things on paper so you can see the patterns. Don't try to hold it in your head. So now let's jump over to our y's. So notice I go from 7 to 8, I go up 1. So my first rate of change is 1 over 1. When I go from 8 to 10, I go up 2. So my second rate of change is 2 to 1. So right now, you should know that it's not linear, right? Because 1 to 1 and 2 to 1 are not equal. So we know it can't be linear. We know it can't be absolute value. So now we're thinking, okay, it's quadratic or exponential. So we want to continue our pattern of rates of change to see, okay, what type of pattern exists within those numbers. So now 10 to 14, I add 4. 14 to 22, I add 8. Okay, 22 to 38, I add 16. And then I add 32. And I'm going to stop right there. All right, now, once again, if we look at how those numbers are changing, right, they're not going up by the same amount. So this goes up by 1, then 2, and then 4, and then 8, and then 16. So it can't be quadratic. All right, can't be quadratic. But how are these numbers changing, right? Can you see that they're multiplying by 2, right? 2, 4, 8, 16. So my rate of change is increasing by a factor of 2. And we definitely want you writing that out, right? And that's why it's an exponential function. So we want you to get in the habit of, right, using the vocabulary, putting it on paper. All right. Okay, now let's jump to number 2 here. Let's look at this. So once again, scan this table, right? Do you see a turning point? I do not. Okay, it looks like it's going down the entire time, right? Okay, so probably not absolute value, probably not quadratic, but we have to verify. Okay, so let's jump in and look at our rates of change. Now, once again, I'm gonna look at my X column here first. And I see that they're all going up by 1. So they're all increasing by 1. All right, so now let's look at those changes on the right side. And I'm gonna use my calculator here, so I'm gonna find that first rate of change, and I went down by 4,074. That's a lot. All right, so my first rate of change is negative 4,374 to 1. And then when I go from 28182 and then minus 724, that rate of change is negative 1458. All right, over 1. Okay, so pause right there. So right now, after the first 2 rates of change, you should know, can't be linear, can't be absolute value. We do not have a constant rate of change. All right, so now we're down to exponential, quadratic. And I'm probably leaning exponential because I don't see a turning point, right? So I'm gonna lean exponential, but I'm gonna verify it through the pattern in my rate of change. So let's keep going here because these numbers are pretty big. So let's go 724 to 238. And I go down by 486. So 238 to 76. I go, whoa, I hit the wrong button there. So let me do that again. 238 minus 76. I go down by 162. 76 to 22. I go down by 54. 22 minus 4. I go down by 18. And then I go down by 6. All right, so now the question is, all right, is it exponential? Is it quadratic? All right, now I'm going to work with these numbers down here just because I think working with some of the smaller numbers to see my initial pattern might be helpful, whereas some of the big times if I'm working with the bigger numbers, it might be a little bit harder. So notice what I see here. When I go from negative 54 to negative 18, I actually go up. All right, and so when I go from 54 to 18, I actually went up by 36. All right, and when I go from negative 18 to negative 6, I go up by 12. So now, right here, I should know it's not quadratic, because if it's quadratic, the second difference would be the same here. They'd be changing by the same amount. So now my question is, okay, it's not quadratic, so what's my pattern here? All right, I'm going to do one more change. Let's go look at this one. Let's see what happens when we get right here. All right, so I went up 108 there. All right, so now 108, 36, 12. So one is I should know that this is decreasing, right? Because these numbers, right, are getting smaller, right? Or my rate of change here is getting smaller, right? I'm adding 108, then I'm adding 36, then I'm adding 12. So my rate of change is definitely decreasing by something, right? So it's decreasing by, and if I think about it, when I go from 108 to 36, I may not know that, but how do you go from 36 to 12, right? I divide by 3. And what I can do is I can double check that. I can do 108 divided by 3, and I get 36, so it works. And matter of fact, if I go back up here, if I divide all these by 3, it works, right? 54 divided by 3 is 18. 18 divided by 3 is 6, right? So then there's that. All right, and I forgot my factor of 3. All right, and so now that definitely means it's an exponential function. All right, so that wraps it up for our lesson on exponentials. We'll continue this conversation. So once again, anytime you're watching the videos, if there's something that you don't understand, highlight it, circle it, take mark it off, put it in your notebook, do something, and then that way you can come into class with those questions ready, and we can clarify your understanding. So we'll see you in class and have all those questions and your work ready to go.